A very good morning to one and all present here. So today we are gathered here to, today we are gathering here
Um,
uh, to listen.
you are audible. You are audible. Please
Yes,
go
sir.
ahead. Yeah,
I'll
yeah.
proceed. Thank you. So alumni talk on alumni knowledge drop. So by our alumni Ankit Shukla. So he's a research scientist working in Hawaii, Canada. So this session it's about we will have more knowledge on data scientist, data practitioner who works in machine learning domain. So currently he working as a research scientist at Hawaii, Canada. Previously he has experience about in company ThoughtWorks, which works for India. So he is also one of the data scientists in ThoughtWorks in company in India. Currently, he is pursuing his master's in data science at the University of Waterloo, Canada. He has completed his graduation in our university at the year of 2017. Now it's my privilege to introduce Ankit and take over the session. Ankit?
Thank you, sir. Hey, everyone. Good morning. So, thanks for the kind introduction, sir. Um, I'll straight up ahead jump into the presentation itself. Um, so, basically, as sir introduced, I started off my journey with completing my computer science degree from SRM in 2017, where I worked as a data practitioner. And then further on, working as an application developer, got promoted as a data scientist in ThoughtWorks India. And then I thought of pursuing further my master's in computer science and data science at University of Waterloo in Canada, where I also got an opportunity to work as a research scientist at Huawei, where I'm working currently in machine learning and computer vision domain. Today we would be talking about machine learning, what it is. I like to call it ML Katha. Katha, as you all know, is like a Hindi word or even from Malayalam, where it is a storytelling by a pundit about the literatures. And then I would be quickly talking about the options that are or were available to me at times of graduation, and finally we'll go to a Q&A session. Starting off quickly with ML Katha. Now, this is a buzzword that is in the industry. What is machine learning? Machine learning is basically finding statistical distribution that fits massive amount of data. It's basically think about, say, you have thousands of email and you have to tell whether something is a malicious email or not. How will you do that? It's not very easy to program it. There's not a simple logic that you can do it. But said that, it's also not magic. It's just some machine trying to fit some statistical distribution. But most of the time, it's a version of normal distribution or a Gaussian distribution that you fit on huge amount of data. That's what it is. Uh, uh, I think this picture from MIT is a very good explanation of what is machine learning. It's a subdomain of artificial intelligence. If we are looking for some patterns, say if A translates to B or not, then that is called machine learning. If you're looking for patterns in massive amounts of data, that is machine learning. If you know what you're looking for, then it's called supervised learning. If you don't know what you're looking for, it's called unsupervised learning. Um, so, how to understand where all machine learning exists? It's all around us, actually. Right from your spam filters in your email, fraud detection in your bank systems, sales prediction by companies as Walmart or sometimes your big bazaar is also machine learning. Even in healthcare, where you diagnose whether a particular gene sequence can lead to a genetic disorder or not, is also machine learning because it's basically finding a pattern. And at the end of the day, your standard textbooks, which tell you expert systems and recommender systems, they are also example of machine learning. Um, but when and why to use it? I mean, what's the point of using it? Why not just program it simply? Because sometimes it's very cumbersome to add rules. For an example, if you have an apple or orange, uh, I tell you, if in a universe of apple and oranges, distinguish between apple and orange, how would you do it? Maybe someone says that I'll write a program that tells how much percentage of red is there in a picture. And if it's more red, it's an apple. If it's less red, it's an orange. But say if I give you a grayscale image of it, black and white, then you have to write different rules. But as I told, it's very cumbersome to add rules. So sometimes when we enter into these kind of problem domains, specifically something that is closer to humans, for an example, humans just by seeing an apple and orange can tell you it's an apple or an orange. So these tasks, which are complex and inherent in nature, like computer vision or natural language processing, it's not very easy to write simple rules that can program out and help you solve this problem. So you try and to search for patterns that exist in the data and look for it. So if there's a pattern existing in the data, and if the problem is not very numerically solvable, if you cannot find out a relation, if you cannot express it in if then else, then machine learning is a good way to explore it. But a very important caveat in that is you should be aware that enough data should be available to solve these kind of problems. Uh, that's uh, Now what machine learning will do basically, as I told, it's basically pattern recognition. It will see into all the aspects and the variables and attributes that are available. For an example, for an apple and orange, it will not just look at its color, it will explore all the other attributes like weights and texture. Now here you can simply, by looking at this, you can tell that if it's a bumpy texture, it's an orange. But you can see that there's a weight factor too. So machine learning does not just simply looks in single dimension. It looks into multiple dimensions. Then you will say, hey, this is a very easy problem. I'll just put a if condition on texture or weight. I tell you, I give you another problem to classify between cats and dogs, and I give you this data set. And this has two white dogs and two white cats, one brown cat and one brown dog. Just on basis of one feature, you cannot distinguish between cat and dog. You have to combine these features and think about of a cumulative way of saying whether that is a cat or a dog. Now said that, machine learning has two big classes, broadly speaking, which is classification and regression. Now, what is a classifier basically? Classifier is like a black box. It's a function basically. You put in a x and you get a y out. But this y would be a class. For an example, class is a categorical variable to say whether a student is good, bad, or average. If he has his grades above 80, I say he is good. If it's between 60 to 80, I say he's average. If it's below 60, I say he's poor. That means I have attributed these marks to each and every class. There's a category that is assigned to this range of marks. So I input a marks and I get a class out of it. Then it's called a classifier. But there's another class of machine learning which is called regression. For an example, I tell you that in Adyar, if you buy 1 kilometer square of land and you get it for 100 rupees, I'm downplaying the cost too much. But you cannot simply say that if you buy 2 square kilometers, it would be 200 rupees. But said that the price range of the lands would be somewhere from zero till infinite amount of Indian rupees. So when your problem is a range of numbers, it's known as regression. Uh, And as you can see, it's not always a linear graph. You have to consider thousands of parameters. For an example, if you have to predict the price of a house, it's just not the area, it's also the average cost of house in the neighborhood. How close it to a hospital? Which city is it in? Which country is it in? What's the cost of the furniture? Which builder built it? Whether it's in Adyar or is it next to Raj Bhavan? So there are thousands of things that you need to consider. And if it was just one factor, it would have been easier for human to distinguish between uh, whether it is costly or not costly based on just area or the average house cost. But as the number of dimensions increase beyond three, it becomes very difficult for us. And that's another reason that we plug in all this data into the machine, which can visualize, it can understand thousands of dimensions and find the right pattern for you. That's another use of machine learning. And as I said, it's not magic, it's just another tool to make our life easier to interpret the problems that we can simply not codify. Some things to keep in mind: there's not one single solution that fits everything. It's called as a free lunch theorem in no free lunch theorem in statistics. Basically, you cannot like find super advanced machine learning methods that will solve all your problems like computer vision and natural language processing. Um, there's not one. You have to go to the intricacies of all the details in that problem to find the right solution that will fill in. Um, the second thing is there's always a trade off. You might find a very good machine learning algorithm, and usually for huge machine learning algorithms, there are many parameters that are involved. It will be in huge in size, it would be a very big network or a very big graph sometimes. And but computing that will take a lot of time. Storing that might take more time than storing a simple if else logic. And say that you have to put on these model not on a server but on your mobile phone. At that point of time, you have to do some trade off. You have to give off some part of your accuracy to achieve some speed and to achieve some size. And the last thing is, sometimes the simplest solution is the best solution. This is a very old thought from 1700. It's known as Occam's razor. It's not necessarily that you see a problem and you jump in with neural networks, or sometimes a simple logistic regression or fitting a graph with the Gaussian distribution might solve your problem. Um, Further said that, a lot of uh, gyan and knowledge about machine learning. I wanted to share my thought on career pathways. After you graduate, I had these three options, which I would like to present to you all. You can pursue a technical job, or a technical master's, or a business master's. If you're doing a technical job, I would suggest focus on data structure and algorithm. This is the holy trinity and the core of getting a job at whatever dream company you have. If you have mastered this, then always you'll get or you can ace out an interview. Apart from that, at second number is object oriented principle or designs. It's a very important part of most of the interviews that I gave. uh, so far I have given I think for my undergrad I gave three interviews. After my master's and for my graduate studies I gave seven interviews, and object oriented principle was always one of the components of those interviews. So that's an important thing. And last one is system thinking. Basically, you would be given a set of requirements and you would be asked to design a system. So to check how you design each and every component. For an example, how will you collect data? How will you put in? How will you convert that into an object-oriented design, and how you will program it? And finally, practice makes coding and maths perfect, I would say. Go to lead code and hacker it and solve as many as problems as you can. Second one is technical masters. Uh, if you want to pursue your technical studies further, you may say it because most of the universities required a good GPA. Universities in Europe usually look above 85%. In US and Canada, they look above 75%. But that's just an entry requirements. Remember, there are like thousands of applicants like you, so it never hurts to get a good GPA. 9+ is always good on your report. If you want to do it in India, write GATE. Focus on your core CS subjects like operating system. Apart from data structures and algorithm, that is straight 15 marks for you. Operating system, computer organization and architecture, compiler design, and theory of computation. But if you want to do a foreign masters, then you have to take a kind of different path. You have to strengthen your technical aptitude. Like it's basically 10 standard maths for GRE, but English is pretty difficult. You might need to focus on that, and TOEFL and IELTS. Another important part of foreign applications is you should have a strong letter of recommendation. That's very important. So any projects that you have done under any professors would be always helpful, or any subject, or any class that you've taken under professor and you have performed really well, that can be also counted into a letter of recommendation. Finally, for B schools, it's if you are street smart and you have a knack for aptitude, if you're performing very good in your social skill, or I don't know what is called nowadays, the personality development as it was called in my days. If you're very good with the math skills like profit loss and all those things that are asked in the first round of interviews, then you might want to consider B schools because you might have a knack for that. As said, quantitative aptitude, verbal aptitude, and current affairs because it's sometimes useful in some B school interviews. Uh, that being said, here's my thoughts on career pathways, and we can discuss it in the later Q&A section. But one important thing that I want to tell everyone and that I have learned over course of after graduating, it's not been much time, but for 4 or 5 years that I have learned is this quote from the movie The Pursuit of Happiness. Don't ever let someone tell you what you can do or can't do. It's sky's your limit. Dream, but just don't daydream. Work hard. Focus on that. Give it time. Time management is the essence. Respect your professors. Whatever they are telling you, follow that. um, that's the only advice I have in conclusion. Um, with that, I would like to thank you all patiently listening to this. I'll pass on my email and LinkedIn later on, and I can stop in to answer any Q&As that we might have.
Yeah, Ankit, it's a very nice, informative session from your side, and I think no post there isn't any comments on that, and they are not queries right now, not raised. If any queries, they'll be contact. They'll give your details. They'll be contact you. I think it's okay. Mm. Now, just you have explained about your research scientist, like in which domain you are working, what is the current trend is machine learning, and that is very useful information. And little bit, you might have explained like in which domain, like what is the data set you are working in for university. Likewise, it might have explained which data set you are working in your university. Research scientist, what's your existing problem? Is it possible?
So currently, my specialization that I'm working on is computer vision.
Okay.
So I'm working on with the autonomous driving team over here in Huawei. Basically, one portion of it is driving assistance. For an example, whether while driving, the driver may fall asleep because it's a common problem for truck drivers. they have to drive for a long duration, how to automatically detect that a driver is getting drowsy and give those suggestions. So one common way of doing this was proposed in 1960s by Pozniak, and since that, per close is one of the standards where basically using computer vision, you extract the eye patches and
Yeah.
see how much in 3 minutes your eyes were closed. So we designed our own neural network, which was inspired by the first three layers of VGGNet, to train in and understand whether the eye captured is closed and open. That's one part to it. And then we attach it with various other sensor data like the speed of the car, the steering angle, and also whether you're yawning or not, whether you are deviating from lane or not. These all things are fed into the network, and then finally, at 100 FPS, 100 frames per second, a comparison, we tell whether the person is drowsy or not. And if the person is severely drowsy, we give him an alert, and then the person can go in. The system was recently deployed last month in China, and it was a huge success. That's a problem I'm working on, and I'm just trying to make it even cheaper so that it's available on Android phones to the common mass.
Yeah, it's a good work. It's really useful for society. I'm also working in that deep learning. Because in automations or it's no solution will not be given by all the sensors. So even computer vision as a sensor, we can identify the obstacles and this problem. So it will be helpful to identify leads to be a research and until and unless if you it will come as a product, so it will not be useful for a society. It should be implemented instead of buying those Tesla cars or any smart cars. So if you got any application and that will be installed for any customers, so that will be very much useful. Yeah,
Yes, sir. Exactly. We are trying to do that, and that's one of the ideas I propose to my team because I don't want to develop something that only rich people can use, basically.
yeah,
So that's why we are trying to move it into Android phones. Now, one of the challenges, as I've mentioned in my PPT, also is like these models are huge, and when we try to put them on processors or phone, there's a huge delay, so the model might not perform. Then we have to do something like quantization, which is like converting 64-bit representation into 8-bit representations and compressing or dropping in some layers that can be compressed down to reduce the size of the model from 100 MB to 80 MB, and the model performs faster, but the accuracy drops. So
yeah.
that's also one of the areas. It's called quantization that I'm working on. I'm trying to most probably by November it should be released into the market. I hope that it's available to the common mass as soon as possible.
Yeah, very good, Ankit. As alumni of SRM, we have implemented something that is useful for the society, and we are very much proud about you. Like soon, it will be have more number of upcoming research products, and will be have patent too. And I think, ma'am asked one of the questions can you suggest some of the specialization courses for students?
If we talk of currently doing just some online courses that they can do, I would suggest doing a course from Andrew NG on Coursera. That's a good starting point. The machine learning specialization on Coursera, and the deep learning specialization on Coursera. Those are the two good courses if they want to get a working understanding. Apart from that, if they want to look into a technical specialization after they graduate, they should look for masters either in Germany or States and Canada, because these countries are high on artificial intelligence and they have specialized masters. like one I am in into artificial intelligence. Does that answer the question, Mark?
Yeah. So I
Another
think, yeah. So seems like those. So now all students are just want to choose, do masters after completion of the graduation. So if they wish to choose masters, you already said like which domain you want to choose depending on the country. Okay. So after that, what will be the area they have to work? Either they are going to work as a research path or scientist, or they can go for any software IT sector related job in across the.
So, unfortunately, after just after the undergrad degree, people cannot enter into data science or machine learning engineer roles. It's one in thousand cases. If the person is super smart and he's already doing an internship at Google, he might get into that kind of role. But usually the case is that after graduating with a CS degree, and if the person has to work, he will get a job as in software development or application development. And within that organization, he has to see if there is any scope for data scientists, because the minimum requirement for data scientists is 5 to 7 years of experience or a master's or a PhD degree. So that's one thing about the job itself. If the person is really interested into getting into research, I would highly suggest to pursue his higher studies in artificial intelligence or data science. Now there are two kind of masters in foreign. One is coursework and one is research based. So research based masters is basically your entire education is funded, but you do research and you do only 4 courses. That's across US, Europe, and Australia and Canada. So you will be just doing research majorly under one professor. It's important to find university and right professor. If you get into another kind of masters called coursework masters, that's like a professional degree where you just do 9 to 10 courses, and you target job specifically. You just want job after graduating. So those are the two ways that a person can get into.
Okay.
um, Two more questions. Any for time management, I think it's important to make a schedule. That personally that I did. Once I joined college, I maintained a sort of diary wherein I divided my entire day into a schedule, because I used to have, I think, from morning 8 till evening 3 or 4, I had my classes. Then I used to work with one of the clubs, like racing clubs or satellite. I worked with the satellite team of SRM University, and after 5, I used to go to my mess, and I dedicated straight 3 hours. Now it's important to understand that we are not machines. We cannot, any human cannot concentrate beyond 20 minutes. So keep those 3 hours, but don't just go into reading. Like, read for 20 minutes, take a break, maybe read another subject, come back to it, solve a problem on Hacker Earth. And but in those 3 hours, uh, just focus on studies, and then after that, you should end your day. Also, do not exhaust yourself just by studies. Do some physical exercises that stresses relieves out the stress and keep you healthy, because a healthy mind resides in a healthy body. So I would say, if you, after your classes, listen carefully to what professors are telling you. Don't sleep in your class, please. Listen to the what professors are teaching you. To be honest, I learned most of the stuff that was taught in the class, and I just used to revise before, because that the textbooks don't talk to you, your professors talk to you. Clear your doubt as much as possible. Reach out to your professors with your doubt, and apart from that, just have a dedicated time slot in your day. and take regular breaks after 20 minutes. I think that would be good. But uh, this then another question is, it's is it better to get some experience after undergraduate and then get into masters, or getting into masters directly after undergraduation? So one thing that I would say is that once we are once we are done with our undergrad, we don't have enough. We have not seen life. I used to think that I have learned a lot after doing 4 years, but we have seen nothing. So it's always good to gain some experience to see what the industry is, because uh, to be blunt, uh, the interview questions can be they will ask you very difficult algorithms, but once you start going into job, they don't make you do that. It's some rudimentary website design and working. Sometimes you will get challenging projects where you have to develop difficult algorithms. But if you're not sure about doing masters, if you're not sure that you want to study further, I would suggest that get into a job, work for some years, explore the IT field, and you might find what is interested to you. Say cryptography is a very difficult subject to you and you might not be scoring well, but after working into industry you might say, hey, cryptography is way cooler than I used to think it, and then you might want to go into masters. But on the other hand, if you are clear about that, hey, you know what, I want to do my research in distributed systems, I want to do my research in uh, machine learning and computer science, please, as soon as possible, complete your studies, because after a point of time, you will get old, and your learning capabilities, and you'll get a lot of responsibilities from families on the other side. So if you know that what you're interested into, then go for it. And other thing is, one thing was that how I came across ML or AI. I would say it was all thanks to my late professor, Dr. P. Mira Labai. He was a great mentor to me, and he was a great inspiration. Labai sir taught me distributed systems. After that, I went into publish a paper under him into the statistical analysis of networks. That was the first time I got a in-depth understanding of statistical application and distributions into computer science domain, and that was my starting point for journey into ML and AI. After that, when I went into the industry, I tried to gather onto that kind of projects, and after that, further understanding that I gathered from distributed systems and AI at SRM, I further took off my journey from there.
Okay, Ankit. I think this is more informative about now they are planning like those who are want to do masters. So now all the students are get into the job first and learning the experience. Then afterwards, which domain they are really interested, they are identified and they're supposed to do masters. So that will be one of the best solution or best way for them. And one more question, like any changes in teaching learning methodologies in abroad due to pandemic? So
Ye- Yes, sir. Unfortunately, COVID-19 is like in India, classes are happening virtually. Um, Classes where you have to go in for seminars, they are happening in person, but most of the courses have moved virtual, like in India, like we are doing at SRM. Um, the courses happen online and there is interactive session. Apart from that, assignments are there as usual. but assignments are made more difficult, so it takes more time. That's pretty much the difference that has happened, but nothing much in terms of learning because thanks to Zoom and other such video conferencing technique, it's more streamlined in a way to say because we can reach out to professors and do split out session. But the only difference is that the things have become more virtual.
Yeah. Okay. You answered like
I think I answered that question. Yeah.
hello, sir.
Yeah, is it audible now?
Yes, sir. You're audible.
Yeah, I mean, if time permits, I just want to ask you a few questions. I mean, what is the your advice for current second and third year students because they are in the position to decide whether they want to go for higher studies or they want to pursue, I mean, pursue higher studies or they want to go for job market. So, what is your advice whether they have to go for higher studies or job market? Because you have done both successfully. From your point of view, we need it.
Thank you for that question, sir. For second years, I think it is very early. I think they should just focus on their core subjects. I think one important common thing amongst everything is a deep understanding of the subjects that are taught at the university. So I think that for second years, it's a bit too early. I think they should focus on their studies and the core subject because by the beginning of third year, most of the core subjects are completed. Uh, and by that point of time, you know what you are interested, kind of get a sense what you are interested into. Uh, Also, kind of look into the departments, try to reach out to your professors, the research they are doing, and try to do a research project under them. So that you see, because research is not everybody's cup of tea. Uh, uh, People might think that doing a master may get them high paying job in US or Canada or Australia, but uh, as your salary increases, so the living expenses also increases. You're earning in dollars, so are your living expenses in dollars. So it's important to understand that if you're really interested for higher studies or not. If in second year, I would just suggest that people should focus on their core subjects and try to analyze what what they are understanding more. Maybe you are more interested into operating system and computer organization, then you should pursue companies like Intel and AMD where you can become a kernel developer. Maybe you are more interested into cybersecurity, then that's after data science. Cybersecurity is the next booming thing in the industry, and next year it will overtake in salaries for data scientists. So that's one thing that I wanted to mention also. In third year, you have to set your foot up and say, hey, you know what, I have to prepare for the job. But one common thing across everything is data structures and algorithm. You have to be strong with that, whatever may be the matter. I mean, you want to do a job or you want to pursue masters or whatever. Data structures and algorithm is a key that I want to say. But somewhere in mid third year, you have to make a decision whether you want to pursue masters, and by that time you would have done most of your core subjects. And if you're really interested into research and studying further into that subject, then people should consider higher studies. Why I say mid of third year, because usually applications intake happens in fall, that is September of every year, and you should keep 1 year between your applications. So mid of third year is a good time to decide whether you want to apply into higher studies at that point of time or not. And the second thing is your financial condition. If you want to do cheap, do it for free, then go to Europe. If you have too much money, then go to US. If you have some money in between, then go to Canada, I would say. For second years and uh, pre-final years ML courses, to start from scratch, I would say start with John Hopkins University specialization on Coursera, and after that go into Andrew Ng's machine learning courses. And there is also a machine learning lecture series on YouTube from Stanford that is free of cost. People should look into that too. Some of the problems that I solved using AI ML, most of them I cannot speak out the details because I have signed contract with companies.
Yeah,
Uh,
that's why I understand it. I can't able to reveal all the problems what you are doing there. So it's a contract based, and you can say like you can suggest the research ideas to the students so that they will be start, not the exact problem. So what all the domains it's there to where the machine learning is really needed. So you can explain those applications. Thank
um, um, so machine learning is in hype nowadays. It when I was in my high school, it was called business intelligence, and then they started calling it data science. And I don't know after 5 years what they will call it, but it has been always there in the industry. But in the beginning, it was mostly used into telecommunication. The biggest companies that hired statisticians was like Bell. After that, now it is there in every industry. I've worked across. I've worked with customers in retail like Walmart and Kroger. These are retailers in US. I've worked with Rolls-Royce and T4G, who are aircraft engine manufacturers. So for retailers, it's problems like they do most of time series forecasting. For an example, how many products were sold and what's the profit margin. Do we need to replenish our stocks? How much in advance should I order? For an example, if I have too much sales of Parle G, should I order 20 more units of Parle G next month? um, uh, I have space for only 10 products on my shelf. Should I increase the size of product? Which product I should display more in my mall? These kind of problems are solved for the retailers. They want to increase. We call it optimizing metric. So basically, you have to identify the right optimizing metric in each and every case. And sales is normally sales and profit is their optimizing metric. Then are the specialized domains like for Google and Facebook, it's natural language processing, how they can automatically convert a text from Hindi to English, or how they can extract emotions out of it. So there are certain combination of words that gives sentences emotion. That's another important domain. Finally, another boring thing is computer vision. For an example, I was telling you about my use case where you have to detect drowsiness. Or it's one of the use cases similarly is, say you go to an exhibition and there's too much crowd and you just want to know what that product is on the other aisle. You can just place your phone and you can crop across it, and the phone will tell you that this is this product. So image recognition, face recognition, emotion recognition using your face, like the facial structure. That's another thing. Um, Finally, apart from that, natural language processing, computer vision. Another good thing is into industry where you have to do process optimization. It's closely related to operation research. Basically, like in Amazon, they have robots to automatically fill up uh, some part of their production house, how they should arrange their warehouses so that the optimum space is there. So it becomes an optimization problem. These are the most common type of things that are out there in the industry right now.
you. Yeah, it's good thing like how the problems is happening in real time. Even what you are saying, like optimization is also one of the problems rather than like giving machine learning problems and all. It's a good thing. Uh, I think further no more worries. Okay, thank you, Ankit.
Thank you,
Uh,
sir.
you have shared your wonderful experience, like starting from machine learning, what which problems you are working for, and then you gave guidelines to our students that who are doing masters. First, we have to cultivate research ideas in you, that which domain you want to work on. So that you have to have your experience in industry for a year. Then you have to choose which university you want to take a masters is it due to for the particular specialization. So then you tell about the common research problems in machine learning, and one of the biggest problem is optimization. So that's also very useful how to implement this, and yeah, really useful. Answer. Yeah, very much. Thank you. Have your yeah.
Thanks a lot, sir.
Yeah, and Ankit, one more thing. Just share your mail ID so that everyone can be benefited by contacting you, especially for current third year and final year students. Okay, can
So
you
should
share your mail ID in a screen?
okay, I'll just maybe uh, just give me a minute, sir.
Yeah, preferably Gmail, right? Okay. So
Okay. Okay, students. So if you want to contact Ankit, note down this mail ID and you can contact at any time. He will be answer your queries in future. Thank you, Ankit.
yeah, thank you. We'll connect.
Thank you.
Thank you, sir.